जी बिल्कुल, we can see it.
Can I get a visual? Can I get a audio confirmation?
Yes, I can hear you.
Okay, perfect. All right, so we can start. Thank you for joining today's session. And this is Park Launch's first experts panel session over here. I would request that if you are not speaking, just go on mute so that we don't get any background noise. You will have ample opportunity to ask questions, so we will have separate time for it. Today, we are going to be talking about microservices as we have publicized. And really the purpose of these sessions is to have somebody who has worked in this field come and speak about a topic that they have direct experience with. And I know that you guys may have a lot of questions in terms of how this is done, and as these are some of the things that you guys may be building. So this initiative is basically about reaching out to you guys directly and making sure that you guys can ask questions and share your experiences and learn from people who have done these type of things before. Now, Khyam, are we recording this session now? Just want to make sure.
जी बिल्कुल, we are recording this.
Okay, perfect. Got it. So let me give a little bit of introduction about myself. My name is Zohaib Khan, and I graduated from Zohaib Khan and the first batch, 97, I guess, yeah. So in computer systems engineering. And then I came to US, and it has been now 20 years. I have been an architect, a developer architect, then became lead, then led teams, and now I lead a division. Essentially, I've been a techie since the beginning of my career, and I have actually done a lot of things, especially the ones that I'm going to talk about here, and hopefully in the future. Right now, I am director at Red Hat for emerging tech business and sales. And a lot of you may know Red Hat from Linux, but Red Hat now makes a lot of cloud software and container platform. So that's a little bit of introduction about myself. Today's discussion, microservices is a very broad and very deep topic, and I think 1 hour is not really enough to cover everything under the umbrella. So what would be a good first session would be to talk about why do we need microservices? What are they essentially? Like, what do they do? Microservices, look at some high-level architect, and then when is a good idea to use them. Consider this session as a brief intro, as I highlighted earlier, and then we will have open Q&A. You can actually ask any questions, and if we can answer, then we will. If we cannot, then we will take that question and come back to you later. Please go and register to parklaunch.com website if you haven't done that already. We will be coming up with a lot of other sessions. So let's get started. So, I took this code from back in 2015, and look what this says. Like, every digital company will be either a predator or a prey. And we have seen the incarnation of this to some extent these days, like companies who have levels in the industry. We have seen companies like Airbnb, for example, like start from nowhere and start to challenge companies like Marriott, Hilton, just because they were able to deliver technology and an idea faster, right? Now, that's the world we live in, and the high-performing organizations are decisively outperforming their lower-performing peers. So when we say high-performing, it could be a startup that's coming up with a very small footprint, and the lower performing peers could be a very big company that has not gotten the technology right yet, but they were there because they had the market share from the beginning. Tesla is another great example. Tesla came from nowhere, and it was a very small company, and then it started to challenge the car makers, and now we see Tesla actually was admitted to S&P 500, which is a monumental moment, right? So technology is actually driving a lot of disruption these days. If you guys follow like State of DevOps report, this is published by a company called Puppet. So what they do is every other year they go back and look at the industry and see what are the trends and what are the things that the industry is using. And they published this report about 2 years ago, and this is what it says. For the companies that are moving faster with technology, there are 200 times more deployments that happen during the week. Their change failure rate is 3 times lower, which means that whenever they introduce a change, their rate of failure is actually lower. I mean, introducing change is not a big deal, but what happens is that we see problems with that. Like, when we make a new release, if there are bugs, sometimes we discover that in production. But these companies have automated to a certain extent that they have mastered the entire notion of releasing faster and also releasing with a lower failure rate. And also recovery from failure is 24 times higher. So which means that if something goes wrong in production, whether it's because of the new deployment or whether something happened, like they get hacked or something, they can recover like 24 times more faster. So imagine a small little company that can actually deliver value very quickly, and it doesn't matter where they started, they can actually catch up to you in very short amount of time. So this is what this report is saying essentially, right? So the bottom line is that every business is now a technology business. If a company today says that, hey, we are going to sell, let's say, clocks, and we are not going to use technology, well, then good luck, because if they are not going to use technology, then pretty soon they will be out of business, because somebody else is going to come up with a similar clock that they are selling, and they're going to market it online and actually reach the scale, and then outperform them or gain their market share. So the bottom line for all of this is that essentially code has no business value until it is deployed. So what this means is that we can actually create, very elaborate architectures or very elaborate piece of code, but if it is not deployed into production and nobody's using it, then there is zero business value associated with it. And that says a lot, because people get obsessed with, hey, I want to use this framework, I want to do microservices, I want to do, God knows what, right? Containers, for example. And that's a good idea. But if it comes at the cost of you not being able to deploy because either you don't know how to do this or it's going to take you a lot of time, then the business value is going to remain zero, right? So that's something that we should keep in mind. And I actually talk about this a lot. So this is basically the evolution of technology. So we will start with the time to value on one side. So when at least when I started in the industry, right, 20 years ago, the development process was waterfall. The applications were largely monolithic applications, like big, bulky applications, mainframes, that kind of stuff. And then the deployment was done on physical servers, because there was no virtualization when I started. There was no VMware, there was no KVM. And then, there were big giant data centers. So this is how the technology was done back in the day, right? And the time to deliver value took months or even years. So I could still remember like doing one deployment in 9 months, and that was the norm, and that was considered a success, right? Then we saw, the evolution of that further. So the time to deliver value actually moved to weeks and months instead of months and years. And what facilitated that was the agile development process actually took hold, and they said no more, waterfall. So we actually need to do 3-week sprints or 4-week sprints or whatever that was, right? And then the application architectures also evolved into N-tier, like 3-tier architecture, 4-tier architecture, away from the monolith. I still remember like magazines publishing client server architecture to be the innovative thing. And when I came to US, I used to subscribe to PC Magazine, and they published like, oh, hey, here's the client server architecture, the future architecture of the application. And I still have one of those magazines with me just as a relic from the past. But that goes to show that, this was the technology back then. And then we started to use virtualization in our deployments. And instead of using the data centers alone, well, we came up with the hosted providers. There was still no Amazon back in the day, but there were like specialty providers that would create small little data centers and sell their services to third parties. So they would host, specialty data centers, and that's what companies would buy. Now, fast forward to maybe, let's say, 2018, for example, now the value delivery has moved days and weeks, right? So if you have an idea and if you cannot take it to the market within weeks or days, then the idea is essentially dead, because that shows that you fail to actually get it to the market either in an MVP form or in some shape or form. What's facilitating this movement is DevOps, first of all. So we've come from Agile to DevOps. So we are bringing development and operations together. And this is because we are achieving scale and also faster delivery. Application architecture has moved to microservices. And this is the evolution of service-oriented architectures. The deployment and packaging has moved from virtualization to containers, and our application infrastructure has moved to cloud, right? So this graphic in one stroke represents the evolution for the past, let's say, 20 plus years, right? And what I can predict is like, the evolution of microservices. Now things are moving towards serverless architecture, for example. So we are going to see a continuum of microservices and serverless for quite some time. And somebody asked me like, hey, what about the monolithic applications? Well, guess what? Mainframe applications are still around, so they haven't gone away. So we still have to deal with these, dinosaur applications even today. But the fact of the matter is, when it comes to delivering the value to the customer, this is how this is going to be done, like microservices, serverless architecture, containers, deploying on the cloud, and using DevOps, right? So I have essentially covered why do we need shrinking of the timeline that the paradigm that we live in. So now let's look at some of the microservices architectures and what does that actually mean when we say microservices, right? So I'm not sure if you guys follow, like there are a few thought leaders in this space. One of them is Martin Fowler, and another one is James Lewis. So he published an article, I think, in 2015ish, when microservices was still in the buzz, right? And this is how he described microservices. It's like a small suite of small services that run their own process, and then they share data across lightweight APIs, especially like HTTP based, and they are built around business capabilities and are independently deployable, and there are bare minimum of centralized management. So I've tried to highlight the biggest takeaways of this. So the best way to visualize microservices is the next evolution of service-oriented architecture. And if you guys have followed the service-oriented architecture, it actually advocated a lot of these principles, like create service for the one business function, deploy the service as a separate unit, so on and so forth. What I think the service-oriented architecture did not do well was to decouple this notion of deployability independently, and also containers facilitated that. So containers actually provided a lot of groundwork that was needed for us to take service-oriented architecture and evolve into a microservices type of thing that is now independently deployable, right? So this is the pure definition of microservices, but that's a lot of words. So let's look at it in detail. So people ask me like, hey, how big should a microservice be? Like, what is the granularity for microservices? Some people actually, what they do is they take their current monolithic application. Like I've seen like people take their Java application and they convert it into containers, and they say, oh, we have created a microservice, right? No, you have not created a microservice. You just packaged your application that was a monolith, and that you packaged in a container and you're running in a container, but that doesn't mean it's microservice. So there are about 15 principles of microservices. I'm not going to cover all of them, but I will come back to it in a separate session if you guys are interested. So give feedback to Khyam, and early on this. If you like this session, we can actually have a follow up that goes into a lot of detail. But just to let you know, microservices, a microservice should be as small as a single responsibility, which means that it should take one application concern and take it and deploy it. So let's say if you have a e-commerce application, customer service, for example, could be a single responsibility. Inventory of your product could be another responsibility. Order processing could be another responsibility, right? And showing the service, showing the inventory online, and so on and so forth. This could be so. Start thinking of vertical business ideas and then carve out your services. So don't go for multiple responsibilities. So your service, like if you have a service that's processing orders and at the same time checking for inventory, that's probably not a good idea, right? That's what this means. Each service should only do one thing and one thing well. And what happens if the service depends or needs something else? Then it should call the other service who's doing something else, and then get the data from it. But this service should actually do one thing only, right? And it's also not about the lines of code, but small enough to fit in your head. So which means that if I can visualize a service in my head and figure it out in terms of bounded contexts, right, then that's probably a good idea to have a service. If I cannot wrap my head around because there's so much complexity, then probably what that means is that we need to further break it down. So order processing is a great example where you will have fulfillment, checking the inventory, and also processing the orders, like 3 different things. And if I start to visualize that, I'll say, okay, if when I visualize order processing, it comes up with like 3 or 4, different things, that's probably a better idea for me to further break it down, right? And then it should be small enough that it can be throwaway and you can rewrite or maintain. So, there's really no right or wrong answer when it comes to microservices, but the idea is that, you should follow good common sense. And if you are overloading too much in one piece of code, then probably it means that you have overloaded that. So that's probably not a good idea. You need to further break it down to multiple microservices. Now, when this movement actually started, there was a counter movement that also came in. And a guy named David Heinemann Hansen, who created the Ruby on Rails and the founder of Basecamp, he came up with a concept of MAJESTIC monolith. And basically the idea was that, hey, monolithic applications are not actually bad. And frankly, I don't consider monolithic applications bad, just, so that you guys know that where I'm coming from. It's just that when it comes to scale, we see some limitations very quickly with monolith. So let's see some comparisons like of majestic monoliths and where are the advantages and where they don't scale. So first of all, I will talk about the advantages. They are easy to develop, and since all the dependencies are included. So if you are starting a project from the ground up, then it's probably a good idea to start with a monolith and then move towards microservices, right? Because all your dependencies are in single place. And if you are one person who's developing this application, then there is really no point in developing microservices, because at the end of the day, it's going to be you who's going to be maintaining that, or 2 people team, for example, right? Another point is like single code base for teams to work on. So, microservices are generally like spread across. So there are like different Git branches for each one of them. Monoliths use actually single code base, code branch, and that could be easy to learn. For example, it's one place to go. There's no need for backward compatibility, since everything is packed into a single application. So if you make a change, then the entire application changes. So the backward compatibility is not needed. And then it's also a single deployable unit, which means that a single var file or a jar file or an EAR file, if you're developing Java, or if you're developing Go, for example, single binary is deployable. Now, the disadvantages of a majestic monolith are like they're hard to, hard for teams to work if they want to scale. So if there are like 5 people who are working on a monolithic application and they are all backend services, then it's probably a good idea to coordinate like who picks what part of the application. Otherwise, people will be stepping on each other's toes. And one person may break the code and they would have no clue that who did that. The rest of the team may not know, right? It takes longer release cycles as you go up, and we will see what that looks like. And it's hard to get away from same language and framework. So back in the day we were using struts as the MVC architecture, and then quickly, like the application evolved and grew from it, and there was a need for another type of architecture. So it's not easy to switch back and forth, and the resistance is very low for these type of applications. So when you decide to go with the monolith, keep these pros and cons in mind, right? So let's see. I mean, when we talk about majestic monoliths, we come across this type of composition. Like we have like 18 plus programmers and several business analysts, project managers, so on and so forth. And we create one big ball of wax of an application. Well, this is not majestic. This is a monolith, right? But this is not a majestic monolith. This is probably like a big ball of wax. This is what I call it. So this has all the symptoms of a giant application, and very long time to market, and very slow, and a lot of people trying to work at the same time, and they could only deliver value in a waterfallish way. And probably the code is so intertwined that if you want to change one thing, then something else breaks. So there's a lot of dependencies that go so probably a good example could be something like this, where we use like 3-tier architecture, and we separate like UI and server side and the databases, for example, right? This is still a relatively better start as opposed to like what we see over here, right? And when it comes to release cycles, the business change request, like 24 weeks is generally an acceptable time frame for these type of big applications. Like if a business comes up with a new idea, like, hey, we got to implement this new feature, then it usually takes this long for us to like create the new feature, QA it, unit test it, so on and so forth. And usually there's not a single feature that's going into production. There's like 5, 6, 10, 15 that are going through, right? And once everything crammed in, then we have a giant testing, QA testing for everything. And if one thing fails, then the entire build goes back. And that's what creates like, all this, back and forth, back and forth, back and forth. And before we know it, it's like takes, 20 weeks or something, right? That's very typical actually for monolithic systems, this long of a release cycle. So what should we do, let's say if we are in a monolithic environment? Well, there's a concept called strangling the monolith. So if you Google search it, the same guy called Martin Fowler actually wrote an article on it. I'm just showing you a visual of what that looks like. So let's say you have a monolithic application and a lot of developers, QA, BAs, this is your team composition. Then basically what you do is you start to identify common concerns and start to separate the concerns into their own unit. And then you basically evolve the application and start separating the concerns and the data layer and the UI layer, so that you can actually change one piece of code without impacting others. And you go through these iterations, and eventually you, on the other side, you come back with independent deployable services. But this is a process that takes time, right? So you have to take this application, which is a monolith, and start to break it down in pieces. But before you break it down, you have to go through refactoring, you have to go through repackaging some of the components, and maybe draw a perimeter around, hey, I just want to, convert order processing into microservices. Okay, so let's first isolate that, because, right now it's all over the place in the code. So if we try to convert that into microservices, anybody came across an application where the logic was written in stored procedures? That I've seen a lot of those applications, right? Those are the hardest to change, because a lot of the data actually resides in the database. And if we were to change that application, then we have to change the data layer, which is the hardest. So it takes time, a lot of time, to actually isolate that application. But there's a process called strangling the monolith. And it does take time a little bit, but when you come out of it, you feel good, because now you're not only you have learned the application in detail, you have also change that application and come up with the microservices. And when you could do only one release in 24 weeks, this is how you can actually accelerate. So the first iteration probably is like going to be 12 weeks, like when you are actually trying to isolate pieces. within that monolith, then you go to 9-week release, 6 weeks, and then you accelerate so much that you can actually release every week. But keep in mind that this is a journey. This is not something that you can actually do in, one day you wake up and you say, okay, I'm going to make weekly release. It takes effort and discipline. And also the patches that you apply for your operating system, JVM, runtimes, for example, or frameworks are also considered release. So if you're not adding any feature, but let's say you are patching the Java version like JDK, OpenJDK, for example, because there's a security problem, that's also considered a release, right? So there's a systematic way to actually come up with the, taking from monolith to microservices. And I can think of one example of a company that actually did this, company called Lyft. They are the competitors of Uber over here in the US. And they started with monolith. And what they did was, since they had to go to the market quickly, that was something that they did. And then quickly they changed into microservices once they had a market share and once the users actually were using the application. So, people actually do that, starting from monolith and quickly come towards microservices. So what does this mean for you as a designer or architect or developer? So for monolith, as we know, this is pre-service oriented architecture days. So you may still start your application over here, or you may come across applications that are written in monolith. Then we came to services, independent services, courtesy of service oriented architecture, and they were getting deployed on the virtualization. When we talk about microservices, we have to take certain things into account. First of all, as I said, like single concern service that is packaged in the containers and should be deployed in containerization technology. So, don't come to me and say, hey, I'm writing this application and this is a microservice, but I'm still deploying in virtualization. Should I call it a microservice? Well, I mean, technically you are writing a small footprint, but you are not getting the benefit of moving fast by not using the containerization, right? That's what I answer people when they come and ask these type of questions. Because containerization actually enables you to move faster, deploy quickly, and introduce automation. It's not that you cannot do it in this virtualization world, but it takes a lot of effort, a lot of time for you to invest in something like this, where containerization gives a lot of things for you for free. So let's look at some pros and cons of microservices. The good parts are faster to deliver. You can use DevOps methodology, right? You can have polyglot microservices, which means that you can use, let's say, Python for one microservice and maybe Java for another one. So you are free to choose your technology or stack for each microservice that as you see fit, right? Not the case with monolith, and probably not the case with service-oriented architecture. And you can introduce new architectures very quickly because you are just creating one small monolith, one small microservice, and if that doesn't work, then you can actually start from scratch again. The bad things are, like, it introduces complexity, because when we see, not one or two but hundreds of microservices, then the complexity of the system grows, dependency grow, and then dealing with data becomes an issue. So you have to be very disciplined, when it comes to microservices. So in a nutshell, we have covered the high-level architecture of what a microservices looks like and what are the pros and cons. Now let's talk about, just because we can write a microservices, is it a good idea, right? Just because, like, hey, we learned a new technology. And I used to do that same thing, like, EJBs came out like back in 2002, 2001, 2002, and that was the hard technology. And I learned EJBs because that was the hard thing to do. And guess what? Every Java project that I worked in, I applied EJBs because, that's what I wanted to do. So it's called resume-driven development, right? And a lot of developers are guilty of resume-driven development. But, we have to, as designers of the system, take a step back and think about it. Like, just because we can do something, is it a good idea, right? So let's see what that looks like. So if we draw this graph in terms of productivity on one scale and the complexity on the other scale, then generally speaking, it's actually more productive to start The green line represents monolithic applications, and the blue line represent microservices, right? So it's generally a good idea to start with a monolith because single code base, everything is there. And if you have a small team, easy to talk to each other. So the delivering of the value is much quicker initially when you talk about monolithic applications. So if you're deciding, hey, should I create a microservice or should I create a monolithic application? Well, if you're starting from scratch, small team, new idea, new thing, don't be afraid to start with a monolithic application. Now, there comes a inflection point where, somewhere along the line where your application grows, right? And that inflection point basically crosses the threshold into, if you keep adding more stuff into your monolithic application, then pretty soon you will realize that the complexity grows so much that it drags the productivity down. And that's the point where you have to probably figure out that this is a time to break down this application into multiple microservices or multiple small applications. And that's when the microservices actually shine. So as soon as you realize like the complexity is increasing, microservices gives you an edge in terms of scaling it out. So you can actually scale your team, you can actually scale your system, and you can develop more and more very quickly, right? Um, Distributed computing is great, but there are a lot of things that you have to keep in mind, like scalability, performance, reliability. I'm not going to go into every one of them, but the thing is that all of these things are a concern of themselves, right? So when we talk about distributed systems, microservices are distributed systems. So you have to take care of all these things. And this is an example of like somebody created a robot killing chopper, chopper killing robot, and it actually, there was an error and it actually, basically crashed on DC, and it was like a software bug, right? People call it. So it was attributed to bad software. But the reality is that it is hard to create distributed systems. Why? Because we take all of these things for granted, and they're called fallacies of distributed computing. And what that means is that, everybody thinks that the network is always available, reliable, which means that, oh, if I make a connection, then it's always going to stay, right? Latency is zero. That's a very common mistake. Bandwidth is infinite. Well, that's not really the case. So there will be cases when bandwidth is not infinite, and you will go with low bandwidth to high bandwidth. The network is secure, and this is another thing that we assume. Topology doesn't change. So if you are doing point to point, then later it could be hub and spoke or something else, and there will be one administrator. Well, if the application grows, then we need more, right? Transport cost is zero, and the network is homogeneous, right? So these are all the things that we assume to be true and to be there. But the problem with this is that these are all the fallacies, which means that every one of these things can break, and every one of these assumptions can go wrong. And as a result, your fundamental assumptions for the distributed system can change, and your application cannot adopt. So let's say if we come across a situation where the bandwidth actually goes up and down, then what is your application going to do? Because it always assumes that it can always pull the data from the database, and database is like in, let's say, Karachi, and your application is running in Islamabad. Well, guess what? If the link between Karachi and Islamabad goes slow for some time, I don't know, something happens, let's say, then your application cannot access the database. What is it going to do? Probably is going to break, right? So we don't think about these things, and we consider them, we make an assumption that they're always there, but that's not really the case. And this is why distributed computing is hard, right? Then what about microservice? Well, microservices technically should manage their own data, which means that each microservice should have its own little database, should not expose its database to somebody else. It should only expose REST APIs. It should only do one thing, right? And one thing well. Uh, let's say what has been a function call in your monolith, now it is a network call, because one microservice will call the other microservice, just like shown over here. In a monolithic application, you would say class, new class, and then call that function, and you would be done with it. Now you have to think about network call, right? Polyglot can introduce more problems if you're not prepared for it. So if one person is writing Python code and another person is writing Java code, and both programmers don't understand each other, then that can be a problematic. It can be built, version, and delivered independent of each other. So that's one good thing of microservice. You might be able to retain state or stateless. So microservices could be stateless. And as I said, the way they should communicate is through REST APIs, right? So that's how microservices are generally envisioned. Now, we take an example of Netflix. So Netflix is another company that started doing microservices, I think in 2014, 2013, when nobody was actually thinking about it. And all these things you have to think about when you create microservices. What happens when the service fails? How do I monitor the health? How do I collect and view the logs? How do I collect metrics to automate? How do I scale for demand? How do I deploy? How do I ensure consistency? This is a diagram, I think, from 2013 from Netflix. So, and all these black dots are microservices that they have created for different levels. And look how many connections they have. And let's say if one region of Netflix goes out, they have to quickly be able to isolate that problem, figure it out what's going on, and fix it. So how are you going to identify where the problem is, isolate it so that it doesn't spread, and then fix it, in this mesh of, all these microservices? Like, these are probably like 50 something microservice. So as you can see, the complexity can grow very fast, right? So as a designer, think about the complexity that you're bringing in. I'm not scare you, right? That we are walking on a path that is going to grow, and we have to be able to sustain that, very easily. And if we don't think about these problems, then they will actually fail in the entire system that you're building, right? So, what are the prerequisites? Let's say if somebody asks me, like, when should I create microservice? These are the important considerations for you to think about. Isolate your data. So if you have one database across multiple systems, that's probably a bad start. So you should have one single database for one service. So you should have isolated database, so you have to think about that. Design for failures, right? So consider failure as one of the things that you will encounter. APIs are critical, so which means that having the contract between the services is more important, right? Don't share the database. Hey, if I want to pass data from one microservice to the other, the fastest thing to do is, oh yeah, query my data tables. Here are the tables. Take a look. No. Once you do that, then you cannot change your database because somebody else is looking at it. That's a mistake, right? So expose some APIs and let them call those APIs. That's how you do it. Plan to scale and do load testing. Cut out manual steps. So automation is key. So if you have not automated manual stuff like create build, deploy build, run build, do unit testing, for example, and to some extent QA testing, you can actually script it. If you haven't done that, then you are going to spend a lot of time. So think of automation first. CI/CD, continuous integration and continuous delivery. Think about that. That's actually something that you actually need. Security, right? So access control, encryption, and having different users for different roles, and encrypting storage, storage as a service, and using containers. So these are all the concerns that you have to keep in mind, and some of them are given. So let's say when you're creating microservices, you are probably using Docker or you're using Kubernetes, so that's a good start. But all these other things are not given to you for free. You still have to think about data. You still have to think about CI/CD, continuous integration, continuous delivery. You still have to think about security. Just because you're using Docker doesn't mean that you get everything for free, right? Or Kubernetes, you're not getting everything for free. You as a designer have to think about it. So what's the takeaway from all this? You should design and go for microservices when you want to achieve agility, right? If you are somebody who was writing system and your team has grown and now you are feeling that I have to deliver faster, then that's the point when you can say, okay, microservice is probably a good fit for me now, because now I've outgrown my system and I've outgrown my team, and now I have to implement this. Now, should you start from microservices on day one? Yes, you can, and it's probably a good idea to keep all the other things in mind. So you have to take care of, all the other things, and technology allows you to do that. So there are we make a product called OpenShift that gives a lot of these things for free, like CI/CD pipeline and automation and everything. So let's say 1, 2, 3, 4, 5, 6, 7. So out of these things, maybe 5 things you will get from OpenShift out of the box. So the rest you still have to work on. So you can actually shorten your time to market by making a decision. So there are good things that you can do by starting with microservices if you are doing a new system development. But if you're coming from a monolithic application, then when you decide to move to microservices, when you say that, okay, I need more agility to deliver value. So I would like to close here. I know that was a lot of slides, and I took 40 minutes of your time. So I'll stop here and see if you guys have any questions. And let me know whatever I just said was useful or it was like, okay, we already knew that, so there was no point.
Hi, Zohaib, this is Farooq. Great presentation, and thanks for taking some time out. I have a few questions. I'll start with the front-end integration with microservices. What's the best solution over there? Keeping front-end monolith and integrating with all microservices at application layer, or having each microservice its own front-end?
Yeah, that's a great question. And the background on this is that what generally happens is that when we think of microservices, we generally think that the backend services are microservices, right? That's the tendency. I mean, I used to think that, hey, if I'm going to write microservice, then there's probably a backend service that makes some database calls and that makes some backend calls and then give the data out. But I don't care about the user interface. And user interface is probably written in Bootstrap, jQuery, and or Angular framework, for example. So you are absolutely right. We have to think about the user interface as a monolith as well. So let's say if you have created a website, what's a good example? Amazon.com, for example, right? If you go to Amazon.com, when the site loads, right, probably they started with a monolithic framework, they created, HTML, CSS, and then they created something. So the entire UI has to be loaded once, and there's no way you can load pieces. So when we are thinking about microservices, you have to think all the way from user interface to middle layer, your business services, to your data. Let me actually go back to the slide, this one, right? So when we are developing applications, we generally think of microservices at these 2 layers. We never think about user interface. So what technically should happen is that your microservice should be single purpose, single business concern over here. But if you are rendering UIs, then you should have a way to divide your UI so that it can load in bits and pieces. So let's say the shell loads once, right? Which means that the entire framework loads once. But there are portions of this application that can be independently rendered, which means that microservice over here is rendering this portion, another microservice over here is rendering another portion. And that's a good way to think about it, because at the end of the day, what's going to happen is that you can actually develop backend microservices, but your UI can take you down because that is a monolith. So I'm in the process of writing a few articles on this actually, and this is a very common problem. So yes, to answer your question, Farooq, you should think about your user interface as also a monolith and start to treat it like one. And go ahead.
So using web components to split UI into multiple components and linking microservices to those web components?
Yes. So, there are frameworks available that allow you to independently render portions of application, for example, and that part loads once. But the pieces, let's say, if you want to show status, if you want to show, let's say, a list or something, then those can be rendered independently. And with the technologies like asynchronous JavaScript these days, you can actually load those things separate. So that's probably a good idea to start looking into.
Okay, thanks a lot.
Mm-hmm. Sure. Let me see if there are any questions in the chat.
Hi Zohaib, this is Danish. I have just one question. Rest, you covered it all. Thanks for that great session. Can you explain how we can perform end-to-end testing in microservices architecture?
So by end-to-end testing, can you give me some specific, like what do you mean by end-to-end testing?
You can say what will be the test cases for QA or automation engineer. Like, let's suppose if any organization is going to the microservices architecture, what will be the role and responsibility left for automation engineer and for DevOps?
I think that you cannot do microservices without an automation engineer, because this is a great example. Like if you are coming from monolithic system and start to break it down, let's say, um, the things that take most time, QA, right? Unit testing, any type of user interface testing. If I can have one person or few people do it, what if I can automate it? So the whole point of accelerating from your 24 weeks to small little increments is to be able to script your tests, and not only test but also the deployment of the application, the making sure the application is up and running, detection of the issues. So every aspect that can be automated should be automated. So I think the role of the automation engineer, or somebody who actually takes the application and automates it, is very critical. In fact, I would say that don't even start writing microservices if your team does not have the capability to write automated tests. And there are ways to do that. For example, there are frameworks available that will allow you to record your QA manually first, and then you can actually execute that automated in the automated fashion. So there are frameworks for that. There are also tests. There are frameworks that would allow you to write your unit test and run them. So like JUnit, for example, that started like 7-8 years ago, and we still use it. So whenever you write your code, you also write your unit test. So that's just good practice as a developer. And we should not be allowed to release our code if we don't write unit test for it, for example, right? But as we go further, like QA testing and release testing and performance testing, for example, there are frameworks available for that, and you should definitely use that. And the point is to not create more work, but the point is to automate the manual steps so that you can focus on creating new business values. I saw the real benefit of that in a lot of projects that I did, because I was literally like leading a project, and it took us about a day or two to complete the code, but the rest of the time was spent on deploying the application, conducting QA test, conducting performance test, moving the build from one environment to the other, and then deploying that, notifying the team, yes, it is ready, and everybody goes on coffee breaks and they come back and say, okay, the system is not working. So they go back again and do whatever, and then they come back, we say, okay, now it is fixed. So all that human in the loop kind of thing. So whenever you see like somebody doing a manual work, that's an opportunity for automation. And in my book, if you can automate it, then you should automate it, right? Because once you automate that step, then it will allow you to move faster, because there is no manual handoff anymore. Once I do a git push, then the entire process of creating the build to deploying it to making sure that the system is up and running without issues, this is all automated. And the notification goes out to the QA team, hey, QA is ready. QA environment is ready. Go ahead and do your QA. And they can fire off their QA scripts and they can run, and they can only do manual testing for the new features that haven't been automated. And then in the next release, those new features will be scripted so that we do an incremental change. So don't try to build your entire QA in one day. Think of each release. So let's say if I make this release, probably the QA for this release is going to be manual, but towards the end of it, it should be automated, because there are tools available for you to capture the QA and then script it out. And then when I make this next release in the 9 weeks, then you still have to do the test for the functions that were implemented for this release, for example, right? You should not be spending manual time anymore. You should only spend manual time for the new features that come out in this. All the rest of them should be automated. Similarly, if I'm making this release, then all the features that were released here should have been automated in the QA, and only the new features that are released can be manual. But then at the end of this, they should be automated because there are tools available that allow you to do that. So to answer your question, yes, automation is actually key.
Okay, Zohaib, thank you for great explanation. I have just one another question.
Mhm.
As you have worked as from migrating from monolithic application to microservices, so can you share your experience about what are the most common mistakes any organization do when they are transitioning from monolithic to microservices? Any kind of common mistakes which everyone can repeat.
Common mistake, in my opinion, the most common one is they think that they don't have to change their application and they can just take their application, convert it into container, and be done with it. That's what people think. When they say, okay, we want to deploy microservices, in their mind, it's just like wrapping their application in a container and be done with it. That's the most common mistake. And that's not a bad start, I would say, but that's just a start. Let me go back to the slide right here. So you can take your application in this, for example, but that doesn't mean that your application is microservices now. You haven't really done anything to break down the concerns. You haven't achieved independent deployability. You haven't achieved independent scale. You haven't achieved, let's say, do by contract, which is like, only share data by contract. You haven't achieved a lot of other things. And if you haven't done that, then don't call this microservice. Call this a MAJESTIC monolith, for example, like, that runs in containers, right? You can, my definition of microservices is that when it can be deployed independently, shares no data, single responsibility, can be deployed in containers, and automated. So at least these 5 or 6 things that I consider very fundamental. If you don't have that, then you are still on the journey, right? You are still in the right direction, but you are not there yet.
Okay, thank you, Zohaib. That's all from me. I think you have many questions in chat box as well.
Okay. Yeah, I mean, let me check if there are any other questions. Yeah, so you can ask, share any code messages.
Hi.
Yes. Go ahead.
Hi, Zohaib.
Was that
I
a
have
question?
to the monitoring
Yeah.
microservices. What are the best practices should?
I'm sorry, you're breaking up. What are the best practices of monitoring? Why don't you put a question? I will read it in the chat. Chat and I will read it. So Zunair, can you share codes of microservices that you have explained? Yes. What I will do is I'll compile some references for you guys, like some articles and some books, and they will be available on ParkLaunch website. So if you have not registered, make sure you register and send an email to the admin. That's how you can reach me. And you can. I should have shared my email over here, but yeah, the best way to reach me right now is this ParkLaunch channel, and we'll make sure I put out my contact information there. So yes, Zunair, I think I don't have the code base with me right now, but I will try to compile some things that you can use to get started.
Hi, Zohaib. My question is that, as you say, that every microservice should have its own database, right? But I see some people creating, let's say, they create a cluster of databases and then they connect services to the same cluster. Let's say they created a DB layer, and then their microservices connected to the same database layer.
Okay.
So if database is down, the whole microservices is down. So what's the best solution?
Yeah, so you're asking this question in two aspects. One is the database as a system, and secondly, the database inside that database system, right? So let's say if I'm running a SQL server, there could be only one SQL server running in my team, right? And that's okay. So let's say if I have one server running SQL server, that's fine. But then each microservice only creates their own database, and only that microservice knows about that. So I can create my own order database. Another microservice can create like inventory database. Third microservice can create user database. And all these databases are not visible to each other. They're only visible to that particular microservice. So that is design. That is a design decision. And I think so. What I'm saying is that this is how it should be done. Now, all these three databases could be living on a single SQL server, for example, SQL Server database server, and that's okay. But as you have pointed out, point of failure, which if that database server goes down, then all the microservices go down. So I think for development, that's probably fine if you have one server running the database, but every database for microservices is isolated, so nobody else knows about them. But when you come to deployment in production, you have to think about these things. Hey, what happens if my database goes down? Then you basically make sure that my database is redundant and I have recovery available in the database. So you can have this as not a single server, but behind the scenes, you can have this like as a replicated database, which is highly available. And to a microservice, all they care about is a connection string. And if this database server goes down, then another one takes over transparently. So there's no impact to the microservice. That's how you architect it, right? That's one way to deal with it. Another way is just, if let's say one microservice is using SQL Server, another microservice is using MongoDB, third microservice is using Redis, then these are three different databases, which means that they have nothing to do with each other. So that's also possible, right? But if you introduce more databases, more types of databases, then obviously the technical complexity also grows. So these are some of the pros and cons and how you can manage.
Okay. My second question is that when you're creating microservices, I mean, you should see how you're creating microservices, how light the microservices. Let's say if one microservices take a lot of load, the whole system, the whole system goes down. It takes all the resources on the same system. So other microservices running on the same system also affects. I know there is a limit. You can use resource limit, but still it's not worth it. I see microservices still struggling to performance.
So you are asking about capacity of the infrastructure, right? So let me give you
not capacity. Sorry. If there's 10 microservices running on the same system, and there is load coming on one microservices, the 9 microservices also affects the load of the one microservices.
Correct. So so if I understand your question correctly, if I have one microservice hogging all the resources of the server, then what will happen to the other microservices, and how should we manage the resource quota, for each, right? So, but first of all, let me say that if one microservice requires 10 CPUs and let's say 32 gig of RAM, then probably not a good design to begin with. So maybe go back and check if you have make some design decisions. So probably revisit some of those. That's number one, right? So if your microservice is that huge, then probably you're doing something wrong there. Now, let's say, hypothetically speaking, if a microservice does require that many resources and your server is only capable of 12 CPUs and let's say 64 gig RAM, so that means that one microservice alone can take half of the resources of the entire server, right? If that is the case, then when you use Kubernetes, like we make the platform called OpenShift, and on OpenShift, you can put resource limits for each of your service. We call it pod. Like in Kubernetes, it's deployed as pod. So on a pod, you can limit the resource utilization of each pod, and you can say this pod can only use 4 CPUs and 16 gig of RAM. And if it requires more than that, then it will not be allocated. So as a result, you can basically distribute your resources justly across all the other services that are running. But there's also one more question that you have to think about is, I'm probably running out of capacity because I'm running so many microservices that sometimes there comes a point that my server is now out of capacity. So unless you are not doing a bad design and you are not doing a lot of data loading that is not needed, assuming that that's the right way to do it or that's how you want to do it, then you also have to think about increasing the capacity and adding more servers. So you can have, let's say, these two microservices deploy on server number 1, but these two could be on server number 2, right? Because you are now running out of capacity, so you need to add more servers. So you also consider the capacity planning when it comes to microservice or any other system. But in Kubernetes, for example, you can actually put resource limits on each one of the pods, and as a result, you can control how many resources each service takes, so it will not starve the other. But if a microservice does want a lot of resources, and because that's how it's written, then you have to make a hard choice. Like, you have to add more servers. So that's how you can do it.
Okay, my last question is,
Mhm.
as you giving an example of OpenShift or
Mhm.
Kubernetes. In your point of view, what is the best architecture design we should follow? Like, there is Netflix, there is Alibaba, there is Kubernetes, and then there is OpenShift.
Yeah. So
So if we see there is a pros and cons, but what is the best architecture design in your point of view?
yeah, so all these things are not design; these are platforms. So Kubernetes, Alibaba is a cloud provider. It's not a design decision. Kubernetes is a platform that you can run your microservices on, right? But as a developer, as an architect, it's you who has to design your microservices and how they talk to each other. Kubernetes, for example, gives you the building blocks. So think of Kubernetes as, you know Lego pieces that and the platform that you can run that on. But it's you who has to assemble the Lego piece and make something out of it. So you can decide to make a car out of it, or a plane out of it, or something else out of it. So Kubernetes is by far the most popular platform these days, Docker and Kubernetes. And wherever you can run these two, then that's usually the best place to go, in my opinion. At least in the US, Kubernetes is the most common one, most popular in Docker. So these are the two ones. And you can run Kubernetes. OpenShift is Kubernetes. So when we make OpenShift, it's basically Kubernetes with a lot of automation. And Imad was also asking what's the best way to do the monitoring. So, there are open source tools available for monitoring, like Istio and Service Mesh and Elk Stack. So if you guys are interested, then I can do my next session is what are the most popular ways to do this. So I can cover that. That's a whole big area that requires a session of its own. But to answer your question, start with either Kubernetes or Docker and start to run that on your local system first. I know that Kubernetes cannot run on your local system, so you need to have your own server, or use Amazon or Alibaba or Azure or Google Cloud, any one of these providers. They offer their own Kubernetes, or you can actually run OpenShift over there. So that's really the best way to get started. All right, so we are
Thanks, Zohaib.
11:04. Sorry, go ahead.
Sorry, just a quick one. Sorry, very much for answering my question. Yeah, definitely it's a good idea to have monitoring part of it, because this is something very important when you have an architecture. Like, in fact, having an experience of designing this kind of architecture before. So I will definitely recommend that if we can have action on this thing, on monitoring part of it. And thank you for your passing all the knowledge. Thank you.
Yeah, no problem. So give us your feedback, like, whether you like this session, you want to have more of these, and if you do, then tell us what topics you want us to come and speak to you about, and we will make sure, because you have to realize, like, we are doing this for the first time, and we want to bring value to you guys, and especially with the people that are doing these type of things. So I hope you got a lot of value out of this session, and also feel free to send your questions and let us know at parklaunch.com what would you like to see in the next sessions. So with that, I will hand over back to Khiam.
Ji, thank you very much, Zohaib bhai. That was a wonderful session, indeed, very, very informative. And as you said, that we have done it for the very first time. So I think you kept it at the right level. It wasn't at 30,000 feet level, and it wasn't like really diving deep into the nitty gritties. But we would definitely be looking forward to the feedback from participants. Please feel free to drop us an email. I have provided the addresses in the chat window. You can take note of that. You can also reach out to us on the WhatsApp. I've given some phone numbers because we would definitely like to hear more from you on how to take this forward. Zohaib bhai, of course, we discussed this, that we will be willing to even go deep dive, and if there is enough interest from the participants, or if there's any particular area, because microservices, of course, is a huge area, and if there is anything in particular that a certain team would like to dive into, so we would be more than happy to arrange a follow-up session, or if there's some area that you guys would want to have a general Q&A session, or you would want to have a more of an interactive discussion, because this was more of a one-way followed by a Q&A. ये भी हो सकता है कि आप लोग कहें कि जी, we want to have an interactive session. We have more of like an not necessarily going through a presentation, but more like covering topics by topics, and they could come up and talk about, this is what these are the problems that we face, or these are the questions that we need answers to, and Zohaib bhai can then take those questions. So we can even have a format, we can as it suits everyone, but feedback is definitely something we would be looking forward to. I would also urge you to get registered at parklaunch.com. And if you go to Park Launch and under the menu Learn, there are different discussion groups. We've also formed a discussion group for expert panel. So you can also drop any follow-up query if you have. Maybe like you go back and tomorrow you think that, oh, by the way, this is something, I forgot to ask. So you can also drop a question over there. You can also drop a question over the emails I've provided. You can also drop the same question or any information that you would want to share with us on the WhatsApp numbers provided. And of course, we will connect you with Zohaib, and definitely would like to have a follow-up session. And once again, Zohaib, thank you very much. This is our very first expert panel session that we are having, and I think it was wonderful, and we learned a lot out of that, and definitely would love to have you again on the forum as a follow-up session.
Thank you, guys.
Okay, thank you, everyone. Allah Hafiz.